we should be able to convert between different units for a substance, so that if we are performing a reaction, we can discuss it in terms of different measurements. This diagram is like a roadmap for how to convert between the different units. So if you are given grams, which is our unit for mass, you're going to use molar mass in your conversion. So remember that molar mass is on the periodic table. It's the decimal number. If you are looking for or starting at moles, you use 1 with mole. If you are dealing with volume, then you're going to be talking about liters, and you're going to use 22.4 liters. And then if it is a problem with molecules, atoms, particles, or ions, you're using Avogadro's number. One way to remember when to use Avogadro's number is to remember IPAM. Ions, particles, atoms, molecules. So if the unit of the number you're looking at is a part of IPAM, you use Avogadro's number. All right, so setting up these conversions, you're going to want to use 2 lines of your notebook paper. You always start with the given that's in the problem. And so the question is, how many grams are in 2 moles of helium? So this is our given, so that's what we're starting with. So 2 moles helium. Notice that we're writing the number, the unit, and the substance. You should always have those 3 things: number, unit, substance. And then we're going to draw our conversion table, taking up 2 lines on notebook paper, so top line and bottom line. We're going to take the moles of helium, the unit, and the substance, and we want to get rid of that so that we can convert it to the unit we want to be talking about. So we're going to take moles of helium and put it down on the bottom. So like you're throwing it away, you're throwing it down onto the floor, coming down diagonal. Then, because we're at mole, which in our roadmap is in the middle, we can go to any other unit that we want. And the question says how many grams, so we want to go from moles in the center to grams. So we're going to put gram on top and then our substance helium. Looking at mole, the number that's going to go in our conversion is 1, because 1 goes with mole. The number that goes with grams is the molar mass that's on the periodic table. So we look at the periodic table, we find the molar mass of helium, and we put it next to gram. Then what we're going to do is we are going to multiply the top numbers and divide by the bottom number. So when I type this into my calculator, I would do 2.00 times 4.003 divided by 1. When we write the answer, the number of significant figures is based on the number of significant figures in the number given to you in the problem. So 2.00 is 3 significant figures. The zeros count because they come after the 2 and there's a decimal. So we're going to write 8.06 grams helium. Number, unit, substance. So when you multiply and then divide, because you're dividing mole, you have it on top and on bottom that canceled, leaving you with the grams of helium, which is what we were looking for. So by using the units, we can figure out the appropriate location for the numbers, and then we can multiply and divide. All right, let's look at another example. So here we're given atoms of silver, so we're starting with Avogadro, and we're trying to go to moles. So we're using this conversion here, starting with Avogadro's number and then going to 1 mole. When we write our math, the table, we start with the given. We bring the unit and the substance diagonally down so that when we multiply and divide it will cancel. So unit and substance diagonally down. Now we're here on our road map. The only place we can get to is the mole, so we're going to put mole on top. The substance stays the same. So we have atom to mole, and that's what we were looking for, so that we can stop here. And then from our map, we know 1 goes with mole. Notice that mole is on top this time, so 1 goes on top. And then atom is part of IPAM, so it's going to be Avogadro's number. So we're going to multiply and divide. When we divide, the atoms of silver will cancel, leaving us with moles of silver, which is what the question is asking us to find. So then when we type it into our calculator, we would do 3.01. Remember that special button for the times 10. It's either a double E or it's an EXP. If you're using a graphing calculator, you would get to it by hitting second, comma, and that will put your E there for you. And then you just have to type in the exponent 23. So you don't need to use the caret function or type in times 10. You're just using that special button. So we've typed in our number, times 1, divided by Avogadro's number. So divide by 6.022, special button 23. Now, for significant figures, we look at our number given to us in the problem, 3.01 times 10 to the 23rd. The times 10 doesn't matter for significant figures. We use it to get rid of anything insignificant, so we can ignore that. And then it's just focusing on 3.01. Since the 0 is sandwiched in between, it counts, so we want 3 significant figures. Now, our calculator is giving us this number. So if we want to go to 3 places, that 8 is going to round the 9 to a 10. So we'll have to carry the 1. That rounds the 9 to a 10, so we have to carry the 1. So it changes to 0.500 mole silver. So there's our answer. Let's try another one. Here we're starting with ions and going to mole. So we're starting down here at Avogadro's number, and we're trying to go to 1 mole. We're using this conversion again. So 7.43 times 10 to the 25th ions, hydroxide. Notice that it's telling you what it is because we haven't talked about formulas yet. We're bringing the unit and the substance to the bottom. The only place we can move on our map is to mole, so we're going to put mole on the top, and our substance stays the same. 1 goes with mole. Ion is a part of IPAM, so that's going to be Avogadro's number. So when we go to multiply and divide, the ions of hydroxide will cancel, leaving us at mole, which is what we were looking for. So we're typing it into our calculator, 7.43, special button, 25 times 1 divided by 6.022, special button, 23. We want 3 significant figures because of the number given to us in the problem. So our answer would be 123 moles. All right, let's look at another one. How many liters are in 3.2 moles? So here we're starting at liters and trying to go to moles. So we're going to be using this relationship. So 3.2 moles, and then we know the formula for water is H2O. We bring our unit, mole, and our substance, water, to the bottom. So if I'm in the center of my map, I can go anywhere I want, and since the question is asking for liters, we're going to go this direction to liters. So we'll change the unit to liters and keep the substance still water. 1 goes with mole, and liters is 22.4. So we put 22.4 on the top. So when we go to multiply and divide, the moles of water will cancel, leaving us with liters of water. And then we say in our calculator, 3.2 times 22.4 divided by 1. This time we just need 2 significant figures because of the value given to us. So we would say 72 liters of water. Let's look at one more. Here we're starting at moles and we're trying to get to grams. So in our map, we're starting in the middle and we're trying to end up here on the left. So 0.0432 moles, number, unit, substance, carbon dioxide. We pull the unit and the substance to the bottom. Since mole is in the center, we can go anywhere we need to go to from it, and we want to go to grams. So we change the unit to grams and the substance stays the same. 1 goes with mole, and with grams is the molar mass. So on the periodic table, carbon has a molar mass of 12.01, and then we have 2 oxygens, so we would do 2 times 16. And we have a molar mass of 44.01 grams per 1 mole. So we can plug that number in to our grams. So see how it's grams per 1 mole? That's why we're using that molar mass. So when we multiply and divide, mole of CO2 would cancel, leaving us with grams. And so we type in 0.0432 times 44.01 divided by 1. For significant figures, the zeros are in front of the 4, so they don't count. So we're looking at 3 for our answer, and we would have 1.90 grams CO2. Make sure you try the problems that are listed on the Google form to see how you're understanding, and if you need to come see me during office hours for tutoring.